Welcome to Voices Amplified, the podcast for showcasing the depth and breadth of individuals and knowledge within SME's additive manufacturing ecosystem. Find stories of individual people, ones who truly inspire innovation and advancement in manufacturing, and the technology and opportunities AM makes possible. These are people who not only make AM technology a practical success, but also enable it to capture the popular imagination. This podcast is powered by SME, connecting people who are passionate about manufacturing. We hope you enjoyed this conversation, and don't forget to subscribe to keep up with future episodes.
Hello and welcome to Voices Amplified, SME's portal to additive manufacturing expertise. I am pleased to be introducing the host for today, John Barnes. John is the founder and managing director of the Barnes Global Advisors, founder and CEO of Metal Powderworks, and the past chair of SME's AM Technical Community Leadership Committee. Welcome, John.
Thanks, Susie. It's been a while. We're back from hiatus. Happy New Year. And with me today, I have a special guest, Dawne Hickton. And we'll go through a bit of her background here in a second. But of course, so Dawne, forgive me, we always start with a bad joke. It's just kind of a thing. Because we went to the beach over the break, so this one's ocean-oriented. Why is the ocean salty?
I don't know, John, but it's nice talking to you, but you start out with that joke.
Because land never waves back.
Oh, no. Yes.
It's pretty bad. But, we can only go up from here. So welcome to the show, Dawne. A Happy New Year.
Same to you, John. It's, again, nice talking to you. Happy New Year. And I'm really looking forward to a great 2024 as things are really starting to pick up in additive manufacturing as far as I can see.
Yeah, it seems like it's an interesting pivot in time. So for our listeners, Dawne has an interesting background, I think, originally from New York. Kind of an established Pittsburgher at this point. A little bit different to our other guests as a trained lawyer, also previously CEO and now CEO chairman, or chairperson, I should say. Mother to 5, as an equestrian mom, which is always an interesting, it seems like that's a habit that I know other people have that can be quite expensive. But I think interesting, as we talk through the background here, so you started off at U.S. Steel. You went to teach law at University of Pittsburgh. You then became CEO of RTI International Metals, which you sold to Alcoa. You then went on to Jacobs to be Chief Operating Officer.
Yes, I started on the board and actually ended up running one of the divisions, their government services business.
And now you are the CEO and chairperson of Cumberland Additive with a couple different locations. And of course, a lot of people will know you as the titanium lady. I believe that's a term that you
that's right.
appreciate from all your background in titanium. So you have this long background in metals manufacturing and precision parts manufacturing. Starting off with U.S. Steel, I guess, the first question is like the transition from law school to U.S. Steel, which then seems to have catapulted you into this metals manufacturing theme in your background.
Right. You could say I started as a steel lady and ended up as a titanium lady, and I'm back to being a titanium lady after a segue in between. I do have to correct you on one thing. I'm a mother of 6. My husband and children will forgive me. So we do have 6 kids and almost coming up on 40 years of marriage. But no, all I ever wanted to be when I grew up was a courtroom trial lawyer, but when I talk to young people about their careers, it's always about the opportunities that present themselves. But, being in Pittsburgh, metals capital of the world, right? And a long history of metals manufacturing. I spent a decade at U.S. Steel, actually as a lawyer, but in the capacity of really spending a lot of time in employment law, traveling to all the different manufacturing sites and really learning a lot about, the manufacturing, the metal processes. Had a short segue over at the University of Pittsburgh to go back. I was recruited back to run some programs in business law and clinical law for a couple of years. And then I was recruited back again into the metals world. And at this point now, it was a titanium company called at the time it was called RMI Titanium. and it had recently been spun off from U.S. Steel, and that was the connection for me. And then I did spend the next 20 years at RMI, that became RTI. During my tenure there, started out as part of an executive team, and then ultimately, moved into the CEO role in 2007. And with a great team of leaders, we were able to take that company from, a couple of $100 million in market cap, ultimately to a little, right around $1 billion in size, doing a lot of organic and acquisition growth at a time when there was a tremendous amount of growth in the aerospace industry. And if you think back, when I talk about the time frame 2005 to about 2007, you had 3 large new aircraft coming into the marketplace. Boeing was coming out with their Dreamliner, the 787. Airbus had just come out with the A350, and then Lockheed Martin was just coming out with the Joint Strike Fighter. And all 3 of those planes were requiring additional uses of the metals, a lot of specialty metals. In my case, we were most interested in titanium. But also in when you thought about making these new products, we were really focused on technology and how could you drive the increased production, the need for newer designs, newer parts, enhanced material products and capabilities. And looking at that as a major supplier within that industry, we were looking at it in that time frame of 2007 and then moving forward a couple of years to meet this growing demand. What were some of the new technologies and new capabilities we could start thinking about for future opportunities? And that kind of segued us a couple of years later into this concept of, a new form of manufacturing, which would be additive.
Yeah, and I think that's kind of certainly where I first came across RTI, being a supplier to Lockheed, which was Lockheed Martin, where I worked. In a lot of sense, when we talk about the additive manufacturing piece, titanium was an interesting case study because it is difficult to machine. It's inexpensive. It's a premium product where you can get by. We measure everything in buy to fly. So, the material utilization is really critical. So when I came to, work for you at RTI, I was hired in that advanced manufacturing capacity, which was a direction some of the other companies were going in, but not everybody. And I would say that was where RTI was a bit different to the titanium companies, is that you really had transitioned from total skepticism of additive to really embracing it. And at that point, you'd been making investments in additive, both with, the Norsk Thai investment, but also with the directed manufacturing acquisition. Can you tell us a little bit about how you went from total skepticism to, hey, this is a thing, but it's not going to be everything?
Yeah, sure, John. The business is a journey. Business is about growth. Life is a journey. Business is a journey. And you're always looking how to not only grow your business, and in our case, being a publicly traded company, you're growing it for the shareholders and the investors, but you're also really focused on how you can partner with your customers. And when I think back to that time frame, it was a huge growth opportunity for titanium with these 3 new aircraft lines, because they were using 4 times as much titanium than any prior aircraft. Now, a lot of that had to do with moving to composites, because the more composite you used on an aircraft, the more titanium you needed. It had to do with the physical, the metallurgical properties of those 2 components together. And then it also had to do with the massive growth. I mean, we were just seeing, the market was taking off for these aircraft. And as a major supplier into that industry, we had to look at how could we take off? How could we supply? And so a couple of things were happening around that time. And I am going to target it around that sort of, after these planes started coming onto the market and they were looking at how to improve the supply chain, we were partnering with the customer and saying, how can we help? Doing a lot of strategic meetings with the customer. I can remember at the time, our team, myself included, flew over to Toulouse to meet with, the folks at Airbus, with their R&D folks and their development people, saying, how can we improve as your supplier? What can we do to make this more efficient? Looking at, all sorts of options. But from our standpoint, it's really in the manufacturing process. How do you move forward? how do you take advantage of new technologies? And if I would fast forward a little bit, it was probably around 2012, people were starting to talk about 3D printing, but for the most part, it was really composites. It was really the plastics world. And I can remember, I think it was maybe 2013, I was at a conference in New York with investors. And at this conference, my counterparts were being asked, what about 3D printing for hard metals? And I can remember the comments that kept coming back is, oh, it'll never happen, too difficult, you'll never 3D print a hard metal. Well, anybody who knows my personality would expect that I came back from that conference and I immediately went to our R&D team. And I said, okay, we melt the metal, we form the metal, we forge it, we roll it, we machine it, we precision machine it, we super plastic form it. I said, why can't we 3D print it? Why can't we come up with, almost like a cafeteria, right? What's the best process for that finished part for the customer? And by best, sometimes that means, how can you get the best quality? Maybe how do you get the best price? And sometimes it's the efficiency of the operation. How can you make the parts faster and get them into that supply chain? And I can remember sitting with our team, and we spent a lot of time talking about this, and they said, well, there are some folks out there that are doing some experimental 3D printing of hard metals. There were a couple of startups. And the first thing I did, before we hired you, John, the first thing I did is I said, well, we need to get somebody who's done it before. And you may recall, we reached out and I met Dr. Kate Jackson, and she at the time was at Westinghouse. And they were doing a lot of 3D printing in-house. And I convinced Dr. Jackson to come over and join the RTI team. And right around that same time, I was working with our own internal company M&A department, the mergers and acquisitions team. And we got together and I said, if we're going to do this, it would probably be too costly for us to do it ourselves in-house. But let's go out there and look at some of these startups and some of these smaller companies that were, dabbling in this, if you will. And that's where we got to directed manufacturing. So it was 2014, and we went in and we looked around the marketplace and we found this company in Austin, Texas, and they were indeed 3D printing very small parts for the medical industry. We're not qualified for aerospace yet, but we decided to jump in, and that was what I would call was the beginning, is it with the shop in Austin called Directed Manufacturing.
And I think this sort of cafeteria approach is appealing to me because there are some that were off saying, well, additive is going to replace everything. It's this total game changer. But the reality is, we've been doing things, we've evolved to do things the way that we have, and we've come up with, castings 1,000 years old with different types of castings and different types of forgings. And so different parts have different requirements. So I think and we're seeing it basically bear out today. So finally, we're coming through this maturation phase where parts are starting to have to drive our decision making, whereas maybe before it was more technology based. I think, it just seems to me that early thinking about the cafeteria was a little bit unusual, but today, it is I would say bearing fruit.
Well, maybe in the broader context, that cafeteria concept might have been not one that others were thinking about, but I can tell you certainly at RTI, when I started there around in the late 1997s, we just had a couple of operation sites, and we were really a tier 4 supplier. So we were making the basic metal into billets and plates and sheet. And when you really thought of how you could move into the production of more of the finished parts or even structural applications, you really needed to move up a food chain. So maybe the food chain and the cafeteria analogies go hand in hand a little bit. But to be perfectly serious, we thought about it at RTI for us to grow the company, to support the customer base, to move into additional product bases and additional industries. We moved a little bit into medical at one point, and we moved and started to grow an energy market. But our predominant markets really were that aerospace and aerospace defense. But as we grew, we acquired a couple of companies along that journey that gave us those different approaches. We acquired companies that did superplastic and hot forming. We acquired a company called Remelian Engineering, which did a lot of precision machining. And then from an organic standpoint, we ultimately built a very large, complex facility up in Montreal that was doing, that structural, finished, and precision machining and ultimately assembly into parts. So as you moved up that food chain, there was that, vertical move, if you will. But then the question became, as you moved up that vertical chain, were there other opportunities horizontally to similarly make the products? You mentioned castings. We had looked at one point about getting into the castings business, but ended up choosing to go into the additive world. But I will tell you, and that's why I think of it as cafeteria. When I would meet with our team, our commercial team, and our engineering team, and when we would go, out to the customer and meet with the customer to say, what are their needs? What do they need? What are they looking for? And again, let's take an example. The 787, the Dreamliner, massive production, new plane, new parts, new designs, and a supply chain that maybe couldn't quite keep up at the time. And of course, that's something we see because it becomes cyclical. We saw that again recently in the pandemic, we can talk about later. But it's during those times when you have an opportunity to meet with your customer to offer solutions. That's how I would really phrase it. And so the cafeteria approach became, if they couldn't get the casting because the castings supply chain wasn't able to make, the parts in sufficient time or sufficient quantity, or even maybe there were quality issues. And when I say quality issues, I mean, as you're changing a design, maybe you had to tweak the quality. And so maybe a traditional approach couldn't reach that certification process. And that was why, as a major supplier of multiple parts into the industry, it was incumbent upon us, I felt, as a good supplier, to really work with the customer and say, what else can we do? Tell us what your problems are. We're going to try to find those solutions. And I would fast forward till today. That's really what we do today at Cumberland Additive. Now today, our GI gets sold. I move off into a different position for a while, but end up coming back to that world of titanium and hard metal, nickel and Inconel, and other metal processing to provide that solution for different parts that maybe can be made best through additive, where maybe the traditional manufacturing is no longer the best way to make them.
So I think, kind of resonating on two points you made there. One is first the quality issue. And this is always that from my experience, you may design a part and there's a perfect design, doesn't mean that it's manufacturable. And so you sometimes have to make a compromise because of the process that, the only process that's out there to make it. And that's where additive kind of comes back and says, well, hey, there's some new ways to think about this. And if you don't have that conversation with the customer, you never know any of this. The second one is, maybe to continue the cafeteria analogy, I probably haven't used this analogy with you yet, but I've described to people like DFAM, this around this idea of designing for the process. But I have, after watching a couple hours of The Bear, the TV show about the chef, and it struck me that a chef is really like designing for additive. So you have a desire, it's about a meal. So it's about the final part. It's not about making just the entree. You actually have to think about the salad and the starches and the vegetables and the beverage that's going to go with it, and even the dessert. And you have to deal with, you want to give that person the entire requirement of the experience, which is, a pleasant dining experience. The reality is, much like we talk about MFAM or modify for additive, you may be stuck with the kitchen that you have. You may not have access to all the fabulous equipment, or you may have customers who are vegetarian or lactose intolerant. So you need to adjust to deal with the environment that you're living with. So anyway, feel free to use that DFAM analogy in your cafeteria pretext. And so just touching briefly on it, because Norsk Thai was in the news recently. They got some parts qualified by Airbus on the A350 after a long period of time. So they're on 787, they're on A350. And this was a company that you had, led some investment in really early on during my first days in the business, which was, Yeah, it's not always about just having to buy the company. Sometimes you can just take a partial stake in the company is a risk reduction. But I think what's interesting on that context, because as you were talking about, you make big parts, you make small parts. You know, at Laval, we made very large parts, seat tracks for 787. So your mindset is I'm not always having to make small detailed things. You know, if I need to solve this customer challenge of, you know, best cost performance or that with that frame of reference, to me, that's what taking this kind of balanced approach to see, hey, what's going to happen? Was that kind of the approach that you were taking there? Just saying, look, this looks like a good idea. We need to check it out. And, you know, 10 years later, it seems to have technically, you know, passed muster.
Yeah, you know, I'm trying to think if I can continue the food metaphor, but I'm not sure I can at this point, John. To your comment, when I think about, you know, the segue to, you know, the investment in Norsk, for example, and some opportunity I had, I actually was recruited and was on their board for a couple of years as they were going through those early stages of working with the customer. What I would say is, you know, back to that application of how we looked at it as one large manufacturer, you can't take away from the partnering with the customer, if you will. And maybe your food metaphor, your restaurant metaphor is, you can be the best chef in the world, but if you're not paying attention to who's sitting at your dining room table and what they want to eat and what they're looking for their palate, you've got to disconnect there. And so if I go back to our, you know, right after we acquired Remily Engineering, I can't remember what year that was, but I want to say it was somewhere around 2011 or 12 maybe. We started doing robotic manufacturing of, you talk about large parts. Yeah, the large parts, the floor structure for the 787 were being done up in Montreal. But over at a Remily operation in Minnesota, we were doing very, very small parts using robotic manufacturing, making titanium tooling for medical instruments and for the robotic surgeons. And these were very small parts that, you know, titanium tooling that would be used by surgeons for microsurgery. So we ran the gamut. And if you think about it, you're not going to be able to make those medical parts the same way you're going to be able to make a large structural part. So now I'm going to, you know, segue that to even 3D printing. 3D printing is another manufacturing process, whether you forge it, cast it, machine it. Now you can 3D print it. But then even within 3D printing, there's different envelopes, right? And so what we do at Cumberland today, and I haven't really kind of made that bridge, but Cumberland today is that old directed manufacturing company that RTI bought down in Austin back in 2014. Today it's under new ownership, new development, new approach. But if you play Cumberland, we're making certain types of parts using certain materials, using certain machines, at a certain envelope size. And then you go to Norsk. Norsk was using a different technology, and they had capability to make larger parts. For me personally, I saw the writing on the wall that these technologies were going to get us there. But, you know, it's not like the Silicon Valley iPhone industry where every 6 months there's a new phone and technology creates a new app. When you're talking about, for particularly aerospace manufacturing, there are very stringent requirements before you put people into a piece of equipment that's going to fly across the globe. And it takes a long time to develop a part, to certify a part, to make sure it meets all of the requirements for use, all of the safety testing around it. And I think, there were a lot of people in the early days of Norsk that were there was a lot of impatience. When are we going to get OEMs to start taking orders and moving in this production? But 3D printing and this type of manufacturing for particular industries requires a lot of patience. And I think you're seeing that pay off today with Norsk with these announcements. They've been working to perfect this technology and to certify and qualify the parts for a significant period of time, but it ultimately does pay off. And certainly those of us in the industry know once you get into a program, then most likely you're in for the life of the program. So those are really positive outcomes.
Yeah, so, and I think that's probably an interesting perspective. You spend a lot of time with the customer and understanding what their needs are and where they're going. You had your time at Jacobs, and I think you probably more or less might have been a customer of additive manufacturing there, or certainly the firms like NASA that you were supporting were. And it always reminds me of my very first boss used to tell me performance is results minus expectations. So if your expectation is tomorrow versus, 10 years, tomorrow you're just always going to be disappointed. And I think the reality is it's 10 years, it's 15 years, it's 20 years, because there are no unimportant parts of an airplane. Especially titanium parts tend to be even more important than most. So thinking about, Directed came back into your life in the form of now Cumberland. It's a parts manufacturing company. It isn't just 3D printing. You also do machining. You have some metals, you have some plastics. And as you think about conversations with the customer, how are you guys approaching the customer with a parts solution as opposed, to the legacy of a shape producer? It's 3D printed, so therefore it's good.
Right, you're right on point, John, and that's precisely the approach we take. So I ended up, as you pointed out, I had this, after RTI was acquired by Alcoa, I had this period of time where I was recruited to run the Jacobs engineering business that was government related. So we did a lot of work with NASA, the teams there. And absolutely, you had a customer, NASA in particular, which loves to try new technologies, and it's incredibly innovative and looking at new ways to make things, particularly in space. And particularly where there's spur of the moment, you've got to make changes, and additive and 3D printing can be helpful for that. But also early days starting to think about getting to the moon project. And if we ultimately start to inhabit the moon and you're out in space, and I'm not talking low Earth orbit. Now we're talking, cislunar, where you get to a point where you might need to replace a part on the moon and you can't call multiple suppliers to get the part shipped. So where they started looking really in an innovative approach to that futuristic world of 3D printing. So you want to talk about having patience, you can run the gamut there. But I'll take that back then when today, being really heavily involved with Cumberland again, our focus and really our biggest customer base includes the traditional aerospace and defense, but a very large growth area for us is space. And a lot of that has to do with that concept, two concepts really. One you alluded to is how do you get with the customer? What do they want? How can you provide a solution? But also back to that supply chain concern that started way back in the 2006, 2007 timeframe. We saw during the pandemic tremendous pressure on all supply chains, not just those for aerospace and defense. And so as we fast forward, we come out of the pandemic, there was a lot of pressure to get that supply chain back up to speed. And a lot of the companies, particularly a lot of the newer space companies, did not have established supply chains, were struggling to find parts suppliers. And that created that opportunity for 3D printing where you could meet with the customer and say, what is it you're missing? You can't get these parts machined because there just wasn't enough machining capacity sometimes. Or other times it was, we need a quick redo here. We don't want to order this part that takes days to machine it. We may want to have you try it out in a prototype, do some composite samples until we get the right fit, the right size, the right complexities, if you will. And then we'll take it and start making it out of the metal. But again, some prototyping and working directly with the customer engineers together as we design those parts that ultimately end up become production parts. So that's, I think that answers your question, but that's a little bit of how we are working today at Cumberland.
And even with the prototyping, so, I would say the origins of Directed was really a prototype shop. It's moved into a manufacturing company. And so I would imagine, this is, I guess, a question, while we say we're making prototypes, I'm assuming it's transitioned to more, there's a path to series production as opposed to this is just a proxy, but we're going to make the cast part in the future or whatever, where we're testing out a shape. But here, I would assume you're doing more like you're working with a company to perfect the shape before it goes into production.
Yes, today we are doing far more serial production or more prototype to production as opposed to pure, let's prototype, let's work, let's sample, let's kind of do a little R&D work. Today, now we're a manufacturing production business. Now, I got back into the company, the year was 2019, so it was right before the pandemic. The company, I don't want to say had been shut down, that's not a fair description, but it really was close to being shut down. There weren't a lot of operations, there wasn't a lot of business. There were one or two production customers, but they were on the composite side that were still active. And by the way, we still have those customers today, very good customers. But it was really, somebody needed to come in and kind of restart this business, if you will. And that's where our team came in. And we got involved in early days. John, you helped us out on that. We recruited a lot of the experts in the field back to come to this location. And we started to, turn things around. And certainly in the beginning, it was prototyping, but always, it wasn't just to do a prototype sample because somebody wanted a sample. It was always a customer relationship to help design a part because they had an issue. And either that issue is the machined part they had wasn't working or they couldn't get it. There were because of the supply chain problems, they just could not get the parts from their traditional suppliers. And then you also had some approaches where it was new designs. Again, I'm going to use the space. It's not just space, by the way, but a lot of the new space companies designing more satellites and rockets. These are new versions that have never been designed before. So they were starting from scratch. And we were working closely with a lot of these companies to help them figure out what types of parts they actually needed. And oftentimes it was a lot cheaper to make it out of a composite as you were sampling before you turned and started using the metal powder, because their cost base is certainly there. But today, in 2024, the majority of what we're doing is now production. We have several customers in space, defense, and the energy markets, where we're actually in serial production of parts now. And the good, exciting news for us about that, to give the team a commercial plug, is once you start showing the success, having replaced parts that came from some of the traditional machining or castings, and you can show the success that we can do with some production parts, then that opens the conversation for what else on this piece of equipment can we do it by 3D printing it and move away from some of those traditional manufacturing processes. But, it's not going to be every part, because if it can be done if it's a simple machining process, you're probably going to you move that to 3D printing. But if it's a very complex connector that has a lot of, here's my metallurgical term, twists and turns in it, it may be better to 3D print something like that from a production standpoint.
Yeah, and I think it always comes back to what problem you're solving. As you're saying, well, if you don't have access to machining, then, maybe solving that machining problem, or it may be solving a cost problem. So, you need to, I think this is the thing of remaining flexible. And it goes back to having the conversation with the customer, which is, what are we doing? What are we trying to do here? So kind of fast forward again. So, Cumberland, of course, was one of the first residents at Neighborhood 91, which is the production campus in Pittsburgh. And you were instrumental in making that early leap into the campus. And I'm assuming that supply chain focused campus was part of the appeal. I mean, I'm sure being in Pittsburgh was an appeal too. Is that, being a part of a production campus and ecosystem, while it's still building out, that was certainly part of the vision that you had for Cumberland there?
Well, I will say, I've got to think about how to answer this, because the way you've asked it, I've got the brains going off in a lot of different directions, because I was involved in the Neighborhood 91 concepts from a lot of different perspectives, the least of which was probably Cumberland Additive, frankly. When I invested in Cumberland and brought a team of folks in as co-investors, the goal really was to ultimately move that whole operation to Western Pennsylvania. Because as I said at the start of this discussion, Western Pennsylvania is that metals capital. It has a lot of expertise. You have the employees, You had at the time, we were looking at this back in the 2018-19 timeframe. GE had a GE additive facility in Pittsburgh. Alcoa had a big 3D printing operation there. So I viewed Pittsburgh, and the fact that I lived in Pittsburgh, as a great opportunity to take this business and see if we could grow it. As I got involved in it, we realized the site in Austin was doing very well. Didn't make sense to necessarily pick it up and move it. But as we started to, and again, I'll have to segue here a little bit. I'll get to Neighborhood 91. As we started to grow Austin, we were finding that we needed a critical mass. We weren't big enough as a lot of these production opportunities came to us. So we would work with a customer, derive the solution, and then the customer would say, well, I'm not sure you're a big enough shop to take our full production on. So again, the solution for us is we needed to, expand our operations. Simultaneously, I'd always in the back of my mind viewed this as an opportunity to get this operation going in Pittsburgh. Hadn't really thought about it as having two locations, but we were now at a critical mass stage where we thought about opening a second operation. At the same time, those thought processes were taking place with the team and we were strategizing. Totally independently, I was involved on part of what's called the Allegheny Conference, which are the business leaders in Western Pennsylvania, the big civic leaders and business leaders and the heads of all the universities get together. And it's all about the economic development opportunities for Western Pennsylvania. Right around that time, they were recruiting a new CEO for the Pittsburgh International Airport. Uh-huh. I was part of the team on that recruitment and got to meet this phenomenal woman, Christina Casotis, who ultimately got the job and is the current CEO of the Pittsburgh International Airport. And she's one hell of a strategic thinker and really growth-oriented and was sitting on a lot of property, sitting on a lot of opportunity. And we ended up in some discussions, and I got pulled into those discussions. I don't know whether you pulled me into them or I pulled you into them, John, but both of us got involved in discussions. And it became about, how can we utilize a lot of this land around the airport that's owned by the airport? How could we make an economic hub? What would be the best use of that hub? And how could we include the traditions of Pittsburgh? Pittsburgh's got a lot of eds and meds today, but it does have that history of metals. But we also have this more recent history of exciting new technology coming out of, the Carnegie Mellon and coming out of the Swanson School of Engineering at the University of Pittsburgh and a lot of robotics companies. And all of that came together with some discussions. And we had one where it was Christina, you, myself, and the Chancellor of the University of Pittsburgh thinking about, what if we make this, an eco hub that takes this new technology for metals and takes it to the next level. And then ultimately that became Neighborhood 91 because, as we know, prior to that, there were 90 neighborhoods in Pittsburgh. That was a historic approach. And so naming it Neighborhood 91 was this great, opportunity to blossom and grow. And we at Cumberland were excited to be able to, this is 24, I think it was in 22, we were able to do the grand opening of our second operations there. And we were the second anchor to the first site of actual physical operations there at Neighborhood 91. So again, kind of drawing from the past and focusing on the future of what you have in a community like Western Pennsylvania. And by the way, it doesn't have to just be Western Pennsylvania, but we've got a lot going in Western PA that's exciting.
Right. And I think probably have to continue our food analogy that the 91st neighborhood will be a dining-centric facility. But going back to Pittsburgh, and I think the little bit of the culture of the place, it knows and loves manufacturing. It's a very good job for people. They appreciate it for what it is. It has transitioned into more of the advanced manufacturing space. It's not trying to retain things that don't make sense. And, the workforce is really critical because we just see over and over again, it's almost a piece of the supply chain. And a lot of these printer manufacturers will tell you, I could sell more printers if I had operators to use them. But, there's a critical gap there. And kind of maybe from our last topic here is really just thinking about the investment in manufacturing broadly. So Pittsburgh, kind of drawing that analogy. So Pittsburgh is a workforce hub, as ordained by the current administration. So one of 5, which I think is a great nod given the legacy of the area. But just generally in terms of investing in manufacturing. And so I like bringing it up a level. And personally, I know you're emphatic about this. I am too, which is investing in manufacturing, at least domestic manufacturing, is not only a good idea, but you can make money at it too. And so, maybe help us close out with a optimistic story about why investing in manufacturing is such a good thing.
Well, I'll tell you, John, this is not a new thought for me. In my pretty lengthy career, I've always been one to really focus on what do we need here in the United States? What do we need in North America? Yes, we're on a global stage. Yes, we were selling to global customers. And even going all the way back to my days at U.S. Steel, we were competing in a global marketplace. And there was a lot of pressure through the years when I was running RTI, and we had to put in new capacity or make capital investments. And there was always a push, you need to go to a low-cost country. But when you're in these industries and you recognize that, yes, there are some benefits of low-cost countries, you're in a global marketplace, maybe offsets apply, but the pendulum can swing too far, because ultimately, when you swing that pendulum too far, you lose the skills, you lose the talent, you lose the capability to actually make the product, and the world changes. I was intimately involved in this right around the time of September 11th, when there was a focus on imposing Russian titanium into the United States and really almost putting out of business some of the domestic suppliers of titanium. And if you think of this conversation, I talked about new aircraft coming on board. One of those was a major fighter jet. Well, you can't make a fighter jet without titanium. And there was a time at which, from a commercial standpoint, at a strategic level, some in the industry were saying, well, let's farm it all out and let's outsource and we'll buy all of our titanium from the Russians. And I don't believe in protectionism for protectionism's sake, but I do think that there's a certain amount of being able to manufacture critical elements and keep critical skill sets available in this country. Because you don't know how the world is going to change. You don't know what your needs are going to be. And imagine, had we allowed the titanium industry to move to China and Russia, where we would be today. And remember, you know and I know, you can't make an airplane without titanium. And if you didn't have the ability to not only make the base metal, but to manufacture some of these really highly critical rotating parts on either the aircraft or the engine, we'd be in a very different place as a country. And I just use that as one example. So for me, it goes to that higher level 40,000 foot discussion, which is it doesn't have to always be, quote, made in America, but you certainly want to be able to maintain capacity and capability and the talent that goes along with it. And when you have that maintained in this country, it also allows for you to continue the innovation and the technology to take it to the next level in this country. Again, I'm not a protectionist, but I do think you can't give it all away. You need to maintain a significant portion of it for not only just basic manufacturing, but also for national security.
Yeah, and it's I think titanium, of course I'm biased because I'm a titanium metallurgist, but titanium is a fascinating study because from the invention of it, and we know today oxygen is such a potent alloying addition, but when so we measure it down to 0.15% or 0.13%. When it was invented, we could measure oxygen at 1%. Yep. So we needed to create the capability to be able to measure it. We had to create the capability to come up with alloys. We had to create the capability to machine it, to form it. It's a very, very tough alloy. So it's an interesting microcosm because it then demonstrates all the other skills that you need to do. It's like having an aircraft carrier. You can't just have an aircraft carrier. You actually have to have a fleet that supports the aircraft carrier. And you have to have airplanes that land on the aircraft carrier and. So I think it's a little bit like you're either involved or you're, just kind of hanging around. So
right. You're on the sidelines. You're on the
sidelines.
Cool.
So with that, I always offer the opportunity to turn the tables and allow the guests to ask a question of me if they would like to. So I'll afford you that that opportunity.
Well, I do have a question for you, John, because as you know, I spent over 20 years at RTI as you pointed out, the titanium lady, and now I'm back, spending several years as a titanium printing lady. But in the middle of that, we recruited you back. You were over in Australia. I first met you when we were recruiting you back from Australia. Dr. Kate Jackson came to me, and we talked about how could we get you on the team. So sure enough, we brought you back, and that would have been around that 2014, 2015 timeframe, if I recall. So what's it like being back in the States the last, 8 years, and any regrets about your career and how it's changed across the globe?
Yeah, I think it's, that whole process of moving overseas is, when I look back on it, I'm really surprised that we did it. My wife Tierney and I are probably a little, I would describe us as risk averse, and yet, we moved halfway around the world with my two girls. And, but I would say nothing, it's a little bit of the nothing ventured, nothing gained proposition. So, I loved my time at Lockheed Martin. Anybody that ever talks to me, I still wear my F-22 pen. It was like such a fantastic, well-motivated team and a great group of leadership that I got to learn under. But even there, the head of Skunk Works was like, you got to go do this. You got to go check it out. You got to go see if it's for you. And if it isn't, you can always come back. And I went and I learned a lot. It was a great experience for us as a family, but it was, from a career prospect, it was also really interesting. I would say, the most interesting point was whenever I'd go give a talk, I'd be introduced as, the Australian National Space Agent or Science Agency. And then here I come with my American accent, and the instant disappointment that I wasn't Australian was something that I had to overcome. So then, moving back and, it was certainly an interesting time to move back, immediately moving into the acquisition by Alcoa and great uncertainty. But, it was from an experience standpoint, it's where else are you going to get that? And, I love the time in Australia. I still consider it our second home. And, but, there is more opportunity here. And so then I was able to start my own business, and it has flourished as a result. So thank you for bringing me back. And I don't know that I thanked you on the first day with the announcement that we're getting acquired, but, eventually it all worked out.
Well, and thank you for being such a good partner, because coming back, we've been engaged a lot over the years. And I'm not sure once we got you here, we didn't know when we recruited you that was going to happen. Those things do happen. Life happens. But the advice listening to you for those who are listening to this discussion and thinking of their own careers, you just never know, right? There's a lot of serendipity. When opportunities come your way, just take them. You never know where they'll lead. And you're in a great place right now. And I think the 3D printing industry, the additive manufacturing industry, from my standpoint, is just on that cusp. And I'm looking forward to some really exciting things as we start to see an acceleration of its adoption in the next couple of years. That's what I'm looking forward to.
Yeah, I think it's the old expression, fortune favors the prepared. So, you keep an open mind. So I think with that, Susie, we'll turn it back to you at the SME studios. And thanks, Dawne, for coming on. And hopefully everybody has a good start to the year.
And thank you, John.
Thank you very much, John and Dawne.
Behind the novel machinery, materials, and finished products are specific individual human beings. We are proud to share their stories. Thank you for listening. We hope you enjoyed the Voices Amplified episode from SME and will join us for future installments. If you like what you heard and want to support the show, you can do so by sharing the show and by heading over to Apple Podcasts or wherever you listen to write a review and subscribe to keep up with future episodes. Don't forget, you can join the conversation and learn more at sme.org.